Keynotes will begin shortly. A reminder to please silence all mobile devices and take your seats. Thank you. This will begin momentarily. Please take your seats. Please welcome to the stage Todd Moore, Senior Vice President, Community Operations, the Linux Foundation.
Hey, good morning. Good morning. Well, we've got another busy day for you today, so welcome back, all of you, those of you who were here yesterday and those who joined us here this morning. I hope you had a good time last night at our reception, got a chance to network, make some new friends. I always like to come to these and make some new friends, so I hope you all do as well. So if you see me, want to chat and say hi, I always appreciate that. So we have a great lineup for you today, and I'm going to start by introducing Robert Nishihara. Robert is the co-founder and CEO of Anyscale. Additionally, Robert, as you may know, is one of the creators of Ray. Great project. I actually a big fan of it. It's a distributed framework for scaling deep learning applications as well as Python applications. Today, Robert is going to discuss how LLMs are changing the way we organize and do AI. So please help me welcome Robert Nishihara.
Thank you. Thank you. I'm Robert, one of the co-founders and CEO of Anyscale. And over the past few years, we've been in the exciting position of getting to work with hundreds of organizations using Ray, our open source software, to power AI workloads. From training GPT-4 to powering deep learning at Uber, to powering AI platforms at companies like Pinterest or Spotify or Samsara. And over the past year, the way these organizations have gone about doing AI, adopting AI, and thinking about AI has changed significantly due to LLMs. And I want to talk a little bit about what we've seen there. First of all, AI has become far more capable over the past year. The kinds of applications people are building today are different qualitatively from the applications many of them were building 1 year ago. But as AI has become more capable, the challenges have grown as well. I want to share a few of these challenges. First is scale. When we started Anyscale, when we started Ray, our bet was that there would be a growing need for scale, for distributed computing to power AI workloads. Now, that may not have been obvious at the time, but today, scale is a fact of life. We see this from models getting larger, not fitting on a single GPU. The data is getting larger, especially as we move from just text data to working with multimodal data, images, and video. And we see organizations routinely using dozens, hundreds, or even thousands of GPUs to power AI across their business. And as scale has become a fact of life, cost efficiency is now top of mind for nearly all of the organizations that we work with. But beyond the scale and cost considerations, one of the challenges increasingly facing organizations adopting AI is the concept of future readiness. They know that AI is moving faster than they've ever seen before. Okay? Many of these organizations have been practicing AI for a long time, pre-deep learning. They've been using AI for over a decade. And they remember going through this transition where they were using classical machine learning models, random forests, decision trees, linear models. And then deep learning became a thing. And they needed to migrate, they needed to adopt deep learning capabilities to make sure their business stayed competitive. But in the transition from classical machine learning to deep learning, many of them found that they didn't have the capabilities to do deep learning out of the box. It's far more data intensive. It requires GPUs now. And so in order to actually adopt deep learning and roll out deep learning throughout their businesses, they had to significantly extend their AI platform capabilities and migrate many of their AI platforms to support deep learning. And this was a long journey for a lot of businesses. Now these businesses that have gone through this migration, gone through this process, are in a similar boat as generative AI takes over, as organizations and departments throughout their companies start to want to use LLMs and other generative models. And as we see this, many of these organizations that have been adopting or have been investing in AI for a long time find themselves lacking the capabilities to fully take advantage of LLMs. And they know that this is not the end. Even as they work to extend these capabilities now to adopt AI and LLMs throughout their business, they know AI is going to continue to change. 1 year from now, we won't just be using LLMs, we'll be using multimodal models. Text data is not actually that big. Once we start working with image data, with video data, to routinely power chatbots and applications like that, the infrastructure challenges are going to become far harder. It's going to become far more data intensive. Okay? So there are more challenges coming down the road. Today, we're largely using GPUs made by NVIDIA. But and those GPUs are getting better and better. The architectures are changing of these GPUs. And there's a rich ecosystem of hardware accelerators that's burgeoning. And so a year from now, many organizations are preparing to have more optionality, to be able to take advantage of a diverse hardware ecosystem. The AI applications that people are building are getting far more complex. For example, we see many organizations starting to use not just one LLM, but multiple LLMs, many LLM calls to power individual applications. And as they do this, techniques like model routing, which automatically select different models and send the right queries to the right models at different times, are becoming more and more important. So these are some of the challenges that we see organizations thinking through. And as organizations adopt generative AI and LLMs, we generally see that happening in two phases. And this happens not as one phase followed by the second phase across the whole organization, but on a per use case basis. The starting point is typically about building and learning. In contrast, when people were doing AI, say 2 years ago, the starting point was typically to curate a data set and use that data set to train a model and iterate on the model. And if the model gets good enough, then you can start to use that to build a feature or ship a product. We're reversing that now. The starting point is now to build a product or build a feature and ship it and iterate on it and validate that the feature makes sense, that it does the thing you want it to do. And at this point, there's a premium on velocity, on iteration. We see companies needing to overinvest or invest heavily upfront in evaluation. How do I know if the chatbot is doing a good job? It's extremely hard to answer. If I swap in this one model for another model, did my application get better? It can be hard to tell. Okay, so this is one phase. And at this point, companies are typically figuring out their overall strategy or approach toward LLMs. Do they bet on OpenAI? Do they bet on open models? Right? Do they train some of these models in-house? Do they learn how to fine-tune or customize models for their different applications? And many organizations are pursuing a hybrid strategy here, where they use a mixture of frontier models from the leading foundation providers like OpenAI, and they also learn to customize models. They learn to fine-tune models as they transition into the second phase of their journey. But at this point, what really matters is about experimentation speed, iteration speed, and validating product market fit. Once you've validated that the product you're building or the feature you're building makes sense, we see organizations double down and really invest. And at this point, you often go beyond the capabilities that you have with existing APIs. You want to customize models more. You might start doing pre-training. You might start using a whole lot of different models. You start using model routing. You start to think about things like scale and reliability and latency and continuing to improve quality. And at this point, what matters is a broader platform that has the flexibility to meet your needs, your current needs and your future needs. I'm going to adapt this application to use multimodal models. Do I have the capabilities to do that? So these are the two phases that we see organizations go through. And many organizations are currently in the build and learn phase. And some of the early adopters, some of the people who started earlier, are just now getting to the point where they've found product market fit for the applications they're building, the products they're building, and they need to scale them. And as organizations go through this journey, the dimensions that they care about when evaluating models, when evaluating LLMs, continue to change. And this is something that will be changing rapidly over the coming years. So today, many organizations are in the process of getting their LLM applications to work at all. And LLMs only became widely adopted over the past year. So the capabilities just became good enough to really support all of the use cases or many of the use cases that people want to build. And because LLMs just became capable enough to enable these applications, quality is paramount. When the top consideration when people are evaluating models today in the prototyping phase is quality. Now, what we're seeing is that models are getting way better. You have GPT-4. You're going to have GPT-5. You have Llama 2. You're going to have Llama 3. The models are going to continue to get better. And as they get better, for many applications, people are finding that the models are becoming good enough. And as the models become good enough, what happens is that the dimensions of comparison can shift rapidly. Instead of caring primarily about quality, people will shift to caring primarily about cost and latency and other aspects of the user experience, or dimensions like privacy and customizability. So there are many different, as organizations go through their journey of adopting LLMs, and as the LLM landscape changes and models continue to improve, the dimensions that people use to evaluate these LLMs is continuing to change, and to change rapidly. We've seen fine-tuning become pervasive as a technique. More and more organizations starting to do fine-tuning. We've seen fine-tuned Llama models outperform GPT-4 and do this at a fraction of the cost. This is a dimension, a knob that organizations have to improve their AI applications and reduce costs once they get to the point of really making these applications real. And the last point I want to make is simply that there's been a massive expansion over the past year of who is even doing AI at the organizations that we speak with. We've seen 1 year ago, many of the people building AI applications were machine learning experts. Today, they're developers, people who care about building products, not about models. And this has placed a premium on usability. People want to treat AI more and more as a black box. And it's a fantastic thing because it means far more people are able to build AI applications. And the number of AI applications we're going to see and use cases will continue to grow dramatically. So this is the right time to be in AI. We're incredibly excited about the changes we've been seeing and that we're going to continue to see over the next year. Thank you so much.
All right, Robert. Thank you. The acceleration that we're witnessing is just stupendous. So, next up, we have Brian Granger. Brian comes to us today as the Senior Principal Technologist of AI Platforms at AWS. Some of you may also know him as a professor of physics. and Data Science at Cal Poly. Brian is going to talk to us about accelerating AI and ML using open source. So please, a round of applause for Brian. Come on up, Brian. Thank you, sir.
Hi, everybody. Great to be here today. I want to talk to you about open source software in AI and ML at AWS. First, a bit about me. In the introduction, you got a little bit of this. Wanted to add a few things. I'm one of the co-founders of Project Jupiter, and I've been working in open source for the last 20 years, involved in a number of different projects along the way. And let's dive into this. So as we all know, it's an exciting time to work in AI and ML. The rate of change, I think, is far beyond any of us could have imagined we'd find ourselves in at this time, and that makes it really exciting, but also really challenging. So what are customers telling us at AWS? One of the things they're telling us is that they want to use popular open source software for AI and ML. They view open source software as a source of rapid innovation, and they want access to that innovation. So from PyTorch to Jupyter, Pandas, NumPy, Spark, LangChain, Ray, Dask, and many other open source projects. At the same time, customers are telling us that they have challenges in using open source software. It's difficult to keep up with fast-moving open source software. It's difficult to configure, deploy, and operate open source software. We find that customers want to use the open source software with the AWS pillars of operational excellence, security, reliability, performance efficiency, and cost optimization. And they also want confidence that the open source software they're using is sustainable in the long term, stable, and continually innovating. So I want to talk to you about two strategies we have for addressing what we're hearing from customers. The first is that AWS and SageMaker specifically offer AI and ML services that bring the value of popular open source software to customers to address these needs and challenges. Some examples. PyTorch. We offer integration with PyTorch in SageMaker training jobs, SageMaker inference endpoints, the SageMaker distribution, which is a package of open source software, a distribution for ML, and SageMaker HyperPod. For Jupyter, we offer Jupyter integration through SageMaker Studio and SageMaker Studio Lab. For Spark, we have Amazon EMR, AWS Glue for Spark, and you can use those things also from SageMaker. The Transformers library from Hugging Face. We offer integration with Hugging Face through training jobs and inference endpoints. And there's many other examples of open source projects that we've integrated into our products and services to serve the needs of customers. But there's a second strategy that I'd like to focus on in this talk, and that is AWS is also participating in and contributing to open source. This part of it is sort of deep in my DNA as a professional, and so it's really fun to talk about this. One example is AWS is a founding member of the PyTorch Foundation and has worked with Meta to create the TorchServe project in 2020, which is an inference server for PyTorch. And in this talk, I want to cover briefly some of the recent contributions we've made to Jupyter, LangChain, and PyTorch. So let's dive in. Project Jupyter. You may be familiar with the Jupyter Notebook. These days, it's a foundational tool in AI and ML. It's a multi-stakeholder open source project, and AWS has been involved with Jupyter for a number of years. We have a team shown here that works full-time on open source employed by AWS, and Jupyter is one of their key areas of focus. So I want to talk about two particular contributions that we've made recently. One is Jupyter Scheduler. So Jupyter Scheduler is an open source extension for Jupyter that enables users to run and schedule notebooks as jobs. We're finding a number of different usage cases for this. One is reporting, running a notebook on a regular basis and producing an artifact that humans can then read as a report. It's a lightweight way for people to move notebooks to production. It's good for experimentation, where you want to run one notebook many times for different parameters. And it's useful for scaling out, where you've been working interactively in a notebook, but you want to run that notebook then on a larger instance type. Jupyter Scheduler is governed by Project Jupyter and was contributed by AWS. So if you're using and have installed Jupyter Scheduler, there's a number of ways to quickly run a notebook as a job or schedule that notebook. There's flexible job options. You can configure parameters for the notebook, pick instance type, Conda environments. You can both run the notebook immediately, a single time, or put it on a periodic schedule. And it uses an immutable snapshot of the notebook, so you never doubt what version of that notebook was run. It's easy to manage jobs. You can download and view outputs of the run notebooks or the logs, delete jobs, rerun jobs, and then edit the schedules. Most importantly, Jupyter Scheduler is extensible. The default backend for Jupyter Scheduler just runs on the system where Jupyter is running. That would often be your laptop. Amazon SageMaker offers a backend for Jupyter Scheduler that runs these jobs on AWS. That backend is also open source. The user interface is extensible, so these extensions or these alternate backends can offer different job options that are sort of specific to the backends. And it's also not specific to just notebooks. A given backend can declare which file types it's capable of running. Next, Jupyter AI. As we know, there's a lot of work being done on generative AI and a lot of interest in accelerating the work of data scientists and machine learning engineers and practitioners using generative AI. And Jupyter is diving into this with Jupyter AI. And there's two primary use cases here. One, using notebooks as an AI playground. And the second is using AI as an assistant as you're writing code and working in Jupyter. Again, Jupyter AI is governed by Jupyter, contributed by AWS. Some of the design principles, and this really follows the design principles of Jupyter itself. It's vendor neutral. So there's a growing list of model providers that are supported in Jupyter AI. It's transparent and traceable. Everything's open source. You can look at the prompt templates we're using. You can customize prompt templates. You can bring your own models to this. It's collaborative. Oops, went too fast. And also, as I said, very configurable and extensible. The first thing we offer is a $% AI magic command that turns Jupyter Notebooks into a generative AI playground. Any of the providers, any of the models that we support, you can do this with. And we support the rich output of notebooks. So for example, here is Claude generating Markdown, and we're able to render that Markdown in a nice form in the notebook immediately. Same is true for models that generate images. We're able to render those immediately in the notebook. What's nice about this is you no longer have to take screenshots of the various model playgrounds to share with your colleagues. You can actually share a reproducible Jupyter notebook with them, showing the explorations you're doing. The second thing that Jupyter AI offers is a chat UI. This is a side panel. You can pick which model you want to use for the chat UI. And this allows you to have a generative AI assistant as you code. You can select blocks of code in notebooks and text files and choose to include that in the context of your request. So you can say, pick a cell, can you tell me what's wrong or help me debug the code in this cell? You can take code snippets that the models generate, insert them back into notebooks easily. It's also collaborative. So as of Jupyter Lab 4.0 and Notebook 7, Jupyter has support for real-time collaboration. So you can deploy a Jupyter server on common infrastructure, and multiple people can log into that and share notebooks and edit the notebooks and view them at the same time. What's nice about this is if you're running Jupyter AI on a server like this, the chat also becomes collaborative. This is just a start. There's many ways that we are finding that we can improve this, but part of, I think, the challenge here is we're all still trying to figure out what are the right patterns for us to interact with generative AI assistants, and how does that interact or interplay with the human collaborations we have. Right now, a lot of the pattern is that we'll all interact with the AI individually and then interact with each other as humans as if nothing happened. What we're finding with Jupyter AI is that's really challenging, partially because of transparency reason, right? That traditional model or that model I think that is the default now doesn't do a good job of showing other people what artifacts that you're bringing to the table were generated or edited or contributed by a generative AI. in Jupyter AI, we're trying, as I said, to increase transparency so that when code is inserted into a notebook, we're tagging the metadata of that cell with the model that was generated. Right? Again, transparency is part of the picture here. Jupyter AI also has slash commands. There are /learn and /ask/ commands that enable you to ask questions about your local files. So you can say, let's say you checked out a repo from GitHub, and you'd like to get a sense of what is in that. You can say /learn, that local directory on your hard drive, and we will go through, parse all the code, parse all the markdown files, call the embedding model of your choice, and store it in a local vector database. Now, I should note, we support many different model providers. Data privacy, we're finding, is really important to users. So if you want, we also support local models. So you can do this with local models, and your data will never leave the system where Jupyter AI is running. Once Jupyter AI has gone through and indexed all this content, you can use /ask to then ask it questions about that content that you've indexed. The /generate command allows you to generate an entire Jupyter notebook from a natural language prompt. This is an example shown there of a notebook that was generated. I guess here the prompt was a notebook that explains how Matplotlib works. We're using LangChain underneath the hood to break that down into a set of subtasks, to have it generate an outline for the notebook, and then fill in the code for each of the sections. It's not perfect. It depends a lot on what model you're using, but we're finding that it's highly useful, enables you to go from 0 to having a lot of code written very, very quickly. And so we're really excited about the opportunities for things like this. In an upcoming release, you can add your own / commands. One thing we're finding with both learn and ask and the generate command is that users want to plug in their own sources of knowledge and their own language models, right? It's not that you're going to have one vector database that you want to ask questions over. In a large organization, you might have dozens or hundreds of different vector databases or other sources that you want to retrieve content from, and dozens of models. And so one way we're allowing extensibility is through / commands. So if you want to have a set of / commands that talk to your models and your sources of knowledge, you can do that. We're also working on natural language routing. So even without a / command, we will be able to route commands based on the natural language prompt to the appropriate vector database or model behind the scenes. Again, all this is extensible. All of it's open source. Come and work with us on this. We're really excited about this. Also, I'd like to talk briefly about our contributions to LangChain. LangChain is a recent, but has become a very popular open source tool for building applications with language models. It provides a full set of abstractions for building applications. It's become very popular with customers of AWS who are building LLM applications using AWS services. We've been contributing since the very start of LangChain just over a year ago. And here's some of the integrations we've built with LangChain. You can use any of the models that you can deploy or use on Amazon, either through Bedrock or SageMaker endpoints as part of LangChain. And then we've also built integration with LangChain for Amazon Kendra, for enterprise search in RAG, OpenSearch RDS, MemoryDB for additional vector surf, Neptune, graph retrieval, and then integration with Textract, Comprehend, and Personalize as well. One last thing, a more recent contribution that just came out at reInvent a few weeks ago is a new Amazon S3 connector for PyTorch. A lot of the data that all of you are using to train models or fine-tune models is on S3. And because of that performance and your ability to load that data quickly, in addition to save and load model checkpoints, is absolutely critical. So this was launched at reInvent 2023 at the beginning of this month. It's a new S3 connector for PyTorch. This is based on a new runtime that is being built for high-performance, read-focused access to S3. At the core, there's a Rust library. It's wrapped up into Python and then adapted to the PyTorch usage cases. So for loading training data from S3, you can load data up to 40% faster than you can through other approaches to working with S3. It offers both iterable style and map style data sets that are compatible with Torch Utils data and also Torch data. And then for model checkpointing, you also see a similar up to 40% performance improvement for that. And importantly, you don't need to save your model checkpoints to the local disk. You can go straight to S3 with this. So to wrap up, open source software provides significant value in AI and ML. Rapid innovation, open collaboration, and best practices and open standards. There's many, many opportunities to participate in open source communities and contribute. And now is a great time to get involved and join us in working in these open source communities. Thank you very much.
Excellent. Thank you, Matt. That was excellent. And thank you for your work in Jupyter and Jupyter Notebooks. Just fantastic tools. The extensibility is wonderful. So our next speaker is Ankit Patel. Ankit comes to us from NVIDIA, where he's a senior director. He leads product marketing for software development kits and developer tools. In his 10+ years at NVIDIA, he has worked on both hardware and software for virtualization, ray tracing, and AI. Today he's going to talk about open source tools from NVIDIA that developers can leverage as they go and build their own AI projects. So Ankit, welcome.
Thank you, Todd. All right, hi everyone. So I'm assuming a lot of you know NVIDIA. If you don't, then you know, the sweater is there to represent. But did you know that NVIDIA has over 500 open source projects? Do you know that NVIDIA products serve basically every single industry out there? So why did I bring that up? Well, the reason is, as open source developers, you should feel confident that you can build your applications on NVIDIA. You have a large market to go reach. There are over 100 million RTX PCs and workstations that you can go run your applications on. We have many developers, startups, enterprises building open source applications and tools on top of NVIDIA. And actually, I mentioned the 100 million. That doesn't even include the GPUs in data centers and cloud. But 500 projects, okay? 500 projects, 10 minutes. All right, let's ready? 9 minutes. Okay, before I talk about the open source, I'm not going to talk about 500 projects. Let's talk about LLMs. And this is one way of looking at the LLM stack, right? Many different layers, lots of different ecosystem tools. NVIDIA's model is that we build the full stack, end to end. The reason we do that is because accelerated computing is a full stack, end to end. It's an optimization problem that requires top to bottom understanding. So we build all the components, we understand the full stack, we accelerate the whole thing, and then paradoxically take it all apart, make it available to the community so that developers can go take the pieces they want, build on top of it. Much of that is open source, and that's what I'm going to talk to you about today, is a few of those tools. As you can see from here, many, many companies that are presented here today, companies that you know about, tools that you use that we, NVIDIA, contribute to regularly. Right? Okay, you guys have probably seen a version of this somewhere. I've simplified it significantly to talk about a simple LLM workflow. So that's the rest of the presentation. We're going to go through these different things. The gray boxes are a subset of the 500 open source projects that you can use as you develop your LLM application. We're not going to talk about all of them. We'll talk about a few of them. But if you're like me, you don't want to start with the data. You just want to get your hands dirty. You want to say, hey, how does this stuff work? So good news, NVIDIA recently announced something called AI Foundations, Models and Endpoints. You can go try it out. Just go there. There's a Gradio app. There's an API playground, so you can use Python curl to start interacting with these models. Just yesterday, we uploaded the new Mistral model. Have any of you heard of this one? This is a mixture of experts model, sparse mixture of experts. If you don't know what mixture is, quick sidebar. Mixture of experts, you have a router model and a bunch of experts. The router decides to use a couple of the experts, and so you have a 47 billion parameter model, but the tokens don't go through 47 billion parameters. They go through about 13 billion parameters. So you get a lot of efficiency. It's a sparse mixture of expert models. Super exciting. Go try it out. That's the URL. Okay, well, and as you can see, there's also Llama and Llama 2. There are Nemotron. There's over a dozen models there to play with. You can go have fun and slide bar it. The Mistral model on there is an optimized model that is accelerated on TensorRT LLM. Okay, so back to what we're talking about. Let's start with data processing. All right, so tool for data processing. Have you heard of NVIDIA Rapids? Okay, good. I see some nodding heads. So Rapids is a library the goal of Rapids is to speed up the data pipeline and leverage GPU acceleration, right? The cool thing that we announced recently, so Rapids, obviously ETL, all the different stages of data processing and even some ML. Recently, we announced a Rapids accelerator, and what that is, it's a CUDA, so CUDF is CUDA data frames, and the Rapids accelerator allows you to accelerate any of your pandas code. The way you use it, you say Python module -m cudf.pandas, and then your script file. And what it'll do is it'll accelerate your pandas code transparently, no code changes. You did not change your script at all on GPUs. So whenever it has if it doesn't support, if the GPU doesn't support an operator, it'll fall back to CPU and keep going. Right? So super, super exciting. There's no reason why you shouldn't try it. It really, if you have a GPU, many do, even on your laptops, no reason you shouldn't try it. Simply just run your script with a command line argument. Hey, quick note, Rapids, massive community. So there's the Rapids project, but Rapids is integrated into many, many hundreds of projects. We have lots of contributors, hugely downloaded. We work with, again, back to my point earlier, we work with the ecosystem. We work with everybody in the community, right? So Rapids is a great project as an example of that. Let's keep going. So you got Rapids, data processing. There's also the Spark. If you're a Spark user, same idea as the Pandas accelerator. There's a Spark accelerator, so you can use the Rapids accelerator for Spark. Let's talk about model training and customization. So one of our projects for model training customization is Megatron LM. So Megatron LM is for researchers who are training massive, I'm talking really, really large language models. The goal of Megatron LM was to train the largest transformer. I mean, you guys know transformer and know Megatron, right? Biggest, baddest transformer out there. And so the idea was thousands, tens of thousands of GPUs. And so that scaling large language models, sharing the work across, pulling it back together is a computer science challenge. Not easy. And so we did all of that work in open source. We had algorithm research, figuring out how to, all these different techniques, model parallelism and, parameter movement sharing, etc. And that is done in this Megatron LM project. And what you'll see, we did this in 2017, I should remember the date. But there's been lots and lots of follow-on work, right? You look at all the different models and things that lots of the community has been able to learn and share from the things that we put in Megatron LM, and has inspired lots of follow-on work to use those techniques to train more and more models. Okay, these are all transformer models. All right, Nemo Toolkit. I'm not going to say much about Nemo Toolkit other than my colleague Elena had a talk yesterday. I'm sure it's recorded. You can go back and watch it. Simply, Nemo Toolkit is an open source toolkit for ASR, TTS, and LLMs. If you go in the GitHub repo, you'll see NLU, same. And there's a lot of things you can do. The Nemo Toolkit actually is another one of the open source tools that was inspired by the work of Megatron. So a lot of those techniques are available there. Nemo is a tool for you to train and fine-tune large language models. All right, let's keep going. So now that you've trained and fine-tuned, optimize and inference. So we have a tool called Triton. So again, another open source tool. You can go to the URL. Triton is a inference serving solution. So once you have your application, you've got to serve all these different things in the data center. Triton supports many different modalities, right? You can do real time, you can do batched, you can do gRPC, you can do REST, all the different ways that you want to serve. It supports many processors, so it supports NVIDIA GPUs, but it also supports x86 and ARM CPUs. There are, actually, let me just jump to the backends. There's lots of backends, right? You can have for large language models, it has VLLM and TensorRT-LLM backends, but it also supports TensorFlow and PyTorch directly, backends for that. We have an OpenVINO backend for if you're going to run OpenVINO on Intel. There's backends for, you can just have your custom C++ or even just your custom Python backend. All these different backends. If you go to the GitHub repository, you'll see the server and then, 30-something backends that are been contributed, either we created or were created by the community. Okay. All right, so you're thinking, wait a minute, that's pretty simple. How did you talk about LLMs and not mention RAG? Okay, let's do it. So RAG, as you guys understand, hopefully most of you know, you got your trained model, but then you have this separate thing where you say, I'm going to take my company data, I'm going to create an embedding model, and then I'm going to use some vector search retrieval, and I'm going to take that data and give it to my model so that when it's generating the data, it's using that information along with the priors that it has been trained on. So again, back to Rapids. So Rapids has a module called RAFT, which stands for Reusable Accelerated Functions and Tools. It's a terrible name. But what it is actually, want to be clear, it is not a vector database. Well, maybe the name is not that bad. It actually is reusable functions. They're accelerated functions for vector search. So we expect developers who are building databases and who are building vector search tools to be able to use Raft to accelerate their vector search and their embedding work on GPUs. We're working with these. You probably recognize some of them. Melvis, Redis, and Facebook AI Research has their similarity search. So again, that's how you can take advantage of Raft. My point here was just to introduce you to a bunch of projects that can help you accelerate your applications. Now, okay, so we talked about basic LLM workflow. We talked about RAG, but you can't build an application nowadays without worrying about safety and bias, right? You kind of have to think about that. And so there's another project called Nemo Guardrails that I think you should check out. Nemo Guardrails is a tool that basically helps you control, like you create rails, and rails are literally just instructions to your large language model. And so when you run your app, you say, hey, these are some rails I want to give you. So the rails are, don't talk about politics. Rails are if you have any insults, respond calmly, like things like that. So you can train your LLM. You have these rails that you can have your application on, and that way, when you build your application, you can control toxicity and bias. So that's kind of it. 2 action items for you guys. Go to the open source page, check it out. We have lots of projects there for you to learn. I just gave you a quick sampling of things that you can use for LLM application development. And probably the most fun thing to do is go to the model endpoints. You can just play with the models, right? You got an interface that you can easily play with the models and try it out. Cool. Thank you.
Thank you, thank you, thank you. Remember those making friends, people with GPUs, make friends with people with GPUs. All right, so our final speaker for this morning is George Castro. George Castro comes from the Cloud Native Computing Foundation. He manages DevRel there. And he's going to talk to us about what's happening at the CNCF and what the Linux Foundation is doing to help shape the future of Gen AI. So George, please come on up.
Hey, how y'all doing today? All right, I'm George Castro. A little bit about myself. I grew up in the Linux era, worked on Ubuntu for about a decade, moved over to Kubernetes when that started to come out post 1.0, and I've worked as a community manager for the Kubeflow communities and Cloud Custodian. These are all cloud native projects, and I am on month 6 of working at the CNCF. On the projects team, there are 174 projects in the CNCF. So when you are perusing the buffet of technology to consume, we're charged with keeping those projects healthy and ensuring that contributors are finding their place and helping to drive the innovation that is consuming so much good stuff. I cannot wait to talk to you. This is my first AI anything. I've been learning a lot, playing with it locally on my computer and just kind of crash coursing myself. I find it having grown up through the Linux era and the cloud native era, it feels like everything just keeps accelerating. And just when I started to get a handle on the software, the hardware is also moving at this absurd rate. So I'm going to tell you today about some projects and organizations that are using cloud native technologies in production. Talking about 20,000 nodes, high throughput computing, about 100,000 jobs scheduled per minute, this kind of scale. This is Kubernetes now. There are CNCF members who are doing this today. I'm going to highlight some of the projects that people are using, and organizations such as Bloomberg, CERN, OpenAI, NVIDIA, and Adobe, and of course Hugging Face. I'd like to talk to you today about the next trillion core hours. We just had KubeCon and Cloud Native Con in Chicago last month, and one of the keynotes was talking about, first of all, it was a reminder that Kubernetes turns 10 next year, and we're starting to come to the point where projects such as this start to need to look at what the next decade looks like. We kind of cut our teeth figuring out the first decade. I was there. It was a lot of how do you get the flywheel going? How do you become more efficient? How do you on-ramp folks? Documentation, all of the things that make open source work. When Jim yesterday talked about how users are kind of demanding that AI be open and collaborative, these are the kinds of things that we're talking about. I'm going to talk a little bit about those in a little bit more detail at the risk of preaching to the choir, because I think it's important for us, especially those out in the audience that might be watching this on video and things like that, that we need to start thinking about the long-term sustainability of these contributors and how we can continue to keep things moving. So what does open look like? So in the Kubernetes mindset, great primitives, API driven, strives to be a universal interface for resource consumption, and users love the extensibility. A lot of the people that are using Kubernetes in production today are using it because of the ability to extend that API and get what they need done. But open also means exercising the processes. That means when end users take the extensibility of those APIs and they're able to move and get what they need in production, that they are able to communicate back to those open source projects to ensure that the common primitives are making it back to core for a few reasons. Maintainability, and it's cheaper. So as it turns out, having end users be able to extend these APIs and then communicate that back into core, making that loop nice and tight and as fast as possible is something that we prioritize. I'm going to talk about a few things today. The first is hardware enablement. This is something that's very front of mind for Kubernetes folks and associated projects, GPUs, TPUs, FPGAs, all of that kind of things. I'm going to highlight two Kubernetes enhancement proposals. That's what KEPS means. The first is going to be dynamic resource allocation. This is an alpha. Is there anybody here involved in these discussions? These are some of the more lively discussions that are happening in cloud native today. This is a very nuanced topic that takes a lot of thought because it does kind of change a little bit on how you might consider how Kubernetes is allocating resources, and that those conversations need to be concluded. And of course, KEP 3545, which is the improved multi-newman alignment in the topology manager, another KEP. There's multiple KEPs in these areas, and then I'm going to show you the website at the end where you can look these up and checking them out. But the TLDR is you all want to slice and dice your GPUs and all that hardware in all sorts of different combinations. Next, I want to talk about workflow enablement. This is about reducing complexity. Index jobs actually landed in Kubernetes 1.24, and job tracking for massively parallel batch workloads, and this is where you're getting up to the 100,000 concurrent pods, that actually landed in Kubernetes 1.26. There's a few batch systems that I'd like to put on your radar. The first is Volcano, a CNCF project, and Q with a K. Make sure you take a picture of that one. And there's also 2 batch working groups I found out, one at the Kubernetes level for the cluster folks, and then one at the CNCF level that kind of covers everything else. So do be cognizant that when you say batch, sometimes you need to be a little bit more specific about where you need to be. Lastly, I want to talk about application development. So I'm a former Kubeflow community manager. Kubeflow just made a release 1.8 in November, and it continues to be used in production, notably at CERN. I always have great conversations with those folks on how they're consuming that. And that project is now in incubation in the CNCF. I'd also like to point out Karmata, which went into incubation yesterday, which is for multi-cluster application management, which I'll get to in a minute. And lastly, I'd like to talk about KubeEdge's Sedna, which is about pushing that AI workload to the edge. There's many nascent projects in this area, and those are 3 that I thought you might want to check out. And of course, as this starts to be consumed more, we're starting to talk about things as they consume those primitives. Users are going to want to be able to grow those integrations with all the other tools that they're using in their clusters, like Caverno and Opa, so all your policy management and all that stuff is lined up. And as I'm talking to people who are doing this, sometimes we kind of wonder, what's the relationship between OCI artifacts and LMMs? Are we just shoving these into registries? I don't know, but I'm really looking forward to seeing the discussions that people come out with. Because for us, it's going to be about unlocking these new primitives and bringing them down to the cluster level. Clayton said inference is the new web app. In the first kind of decade of Kubernetes' growth, it was all about getting those web apps. The first demo I ever ran of Kubernetes was like a web app. So if inference is going to be the new web app, what I really wanted to say today is that Kubernetes is already the web server for a lot of production AI workloads. And as these features and the feedback loop from end users feed back into the system, it will only get better from here. And y'all keep adding zeros to everything. It just makes it really hard. And we're now moving what I call scrambling up that stack, where it's not just about the individual cluster or the individual pods or the nodes. You're now thinking at a multi-cluster level and how we're going to manage that across regions. I think you've sat in enough talks to see the level of scale that some of you are consuming this technology with, and it's really exciting. We'll also take multiple organizations. I'm just highlighting 3 here. The level of complexity that we're dealing with is just something that just one organization can handle. It takes multiple organizations and multiple verticals working together. I know there's many people in this room, you wear multiple hats, multiple foundations, and I just wanted to point that out, that this is something that we're all doing together, because that's what we do. So I invite you to build the scaffolding with us. If you go to Kubernetes.dev, you will find all the KEPs, the enhancement proposals there that you need to be able to go. As with anything with open source, everything is open, meetings are open. Meeting videos are always on YouTube, and we're always looking for people to participate. If you're an end user, thank you. And I will be here all day if you have any questions on how we can help you, and hope to see you all in Paris and next year.
Thank you, George. Thank you. So, thank you to all our speakers this morning. Hopefully you enjoyed those talks, and they will be around. You can find them if you have further questions. We do have more keynotes this afternoon starting at 1:30. It's now time for a break. At 10:30, we'll be back for more conference sessions. So have a good morning, and thank you all very much.
Jacket from the cloakroom, then we hit a couple bars on the way home. I think we got a taxi, but who knows how we ended up at your place alone. Now we're lying here in the morning, and we got a couple missed calls, and we're laughing it out. We got talking it all in. I think it started with, hey, sorry from across the room, and I've been thinking of a way